Mm,
All right, guys. We're back?
yeah.
Okay.
Miss, is this the last session?
Yes, dear.
Okay.
Okay. So we were talking about the forces applied to a toy or an object. Okay. If I have two forces which are equal and they were applied to the same object from the opposite sides, it's not going to move. But if one of those forces, sorry guys, but if one of those forces is stronger than the other or bigger than the other, so the object will start to move. So we have to give those types of forces a name. When the two forces are equal, I need to give it a name. And when the forces are not equal, I want to give it another name, a scientific name, so that we can use them in science. Okay? So, which one do you think will be called the balanced force? When the two forces are equal, when the two forces are not equal? Which one of those will be the balanced force? When the forces are equal?
The two forces are equal.
When the forces are equal, exactly. So when the forces are equal, we call it the balanced force because both of them are equal. So it's like you're putting two things with the same mass on a balance. Okay, so the balance will never move. So this is why we call it a balanced force. Okay, but the one that is when the one of the forces is stronger than the other, we call it what? The balanced or unbalanced? Unbalanced force. Very good. Unbalanced force. So which one of those two forces causes a movement? Which one of those two types of forces will cause a movement? Now you can raise your hand. Now you can raise your hand. Don't answer without raising your hand. Okay? Do you think the balanced force will make the object move, or when it's unbalanced force that's applied to the object that it will make it move? Which one of those two will be responsible of a movement? Yes, Nancy.
If it's balanced, it will not move.
Yes, if it's balanced, it will not move. So the unbalanced force is the force responsible for the movement of an object. The unbalanced force is the force responsible for the movement of an object. Okay? Here in this case, as you can see, guys, this is a type of unbalanced force. It's not necessary have to be two forces trying to push from the two sides. Sometimes, like in this case, for example, there are no force at all on one of the sides. So when you push it, you actually have one force only applied to the object. And on the other side, there is zero force. Okay, so this also is an unbalanced force because one of the forces is still bigger than the other. Do you understand so far, guys? Is there anything confusing so far?
No.
No.
Okay, very well. Okay, so now the question here says, what would unbalanced forces do? It could make everything that we took in the last session. It could make an object start move. or change its direction or change its speed, whether by speeding up or slowing down, or it can actually stop a movement. All of these things can be used by or can be done by the unbalanced force. So the unbalanced force is the one that is making the change. Okay, the balanced force, it doesn't make any changes. The object will be staying still. All right. Now let's go to this. This is actually in your book, and when you take your book, you're going to answer it. I will put it on Classera for you with its answer. And starting tomorrow, I will start giving you homework, and I will be uploading the page as a PDF on Classera so that you can download it and answer the homework, and then you can resend it to me again on Classera. Okay? I know you don't have your book, so this is a way of you doing the homework. But not today. We're going to start doing this starting tomorrow. All right? Okay, so this is worksheet number 1. I will, as I said, I will put it for you with its model answer on Classera so that whenever you get your book, you can write the answers in your resource pack. Now, in this worksheet, it says observations, things move when you push them. Just give me 1 second. Okay, things move when you push them and pull them. So as I said, all of the forces worldwide can be put under 2 main types of forces, which is the push and pull force. Things move when you push them and pull them. A push or a pull is a force that causes things to go faster or slower, or to stop it. When you are very forceful, you give a hard push, you can make a toy car go fast. When you are not so forceful, so you're just pushing it softly, the car will go slowly. Science activity says, do these things need a push or a pull to make them move? Write push or pull under each picture. All right? Okay. So yes, Mira.
This page in
In the third trimester book. Yes. All right. Okay, guys. Who will answer the first one?
Miss, but I don't have the third trimester book.
Yeah, I know all of you don't have the third trimester book. So I said that I'm going to put this and its model answer on Classera. And if I'm going to give you a homework, I'm going to upload the page as a PDF on Classera so that you can answer it and then resend it again for me on Classera.
Okay.
All right. Okay, you're welcome, dear. So the first one, yes, Julie, the first picture.
The first one is pulling.
What? Pulling, yes. So this, they are playing war of tug, and both teams are pulling the rope. So it's a pull force. Okay. Next is this man with the stroller. The man with the stroller. Yes. Abdul Halim, are you there?
Yes.
Okay, what do you think? This man and his stroller, is he pushing or pulling the stroller?
Pushing.
He's pushing the stroller. Very good. Thank you, Hamza. Next is this girl with her ball. This girl with her ball. Amr Hatem.
Yes.
Yes, Amr. Is she pushing the ball or pulling the ball with her legs?
Pushing.
Yes, kicking the ball is a type of pushing force. Okay, kicking the ball is a type of pushing force. Yeah, Hamza, the next girl who's opening the drawer. Unmute your mic.
She's pulling.
She's pulling. Yes, she's applying a pulling force. All right. Okay, let me take Mira. What do you think, Mira? The boy that is trying to put the ball in the net.
He's pushing it.
Yes, he's pushing the ball to be able to put it inside the net. Very good. And the last one, I will take Lena, are you still there?
Yes, I am there. I just cannot open my camera.
Okay, do you see the screen?
Yes.
Okay, this boy is pulling or pushing?
Pulling.
Yes, he is pulling his friends. So it's a pull force. All right. Okay, guys. So that was like a quick revision over the things that we already said in class. And I will be uploading all the videos that you watched on Hamza, is there something wrong? Are you okay? Okay. I'm going to upload all the videos that we watched on in class on Classera too, so that you can watch all of them. Now we are going to talk about one of the most important types of forces, which is the gravity force. And the gravity force is very important to us. Without gravity, we will not be able to stand on the ground. We will not be able to walk on the ground. We will not be able to put our stuff anywhere and this thing stays still in its place. So gravity is very important for all of us so that we can stay on the ground, because the gravity is the force that pulls us to the ground. It is the one that pulls us to the ground. So this means that the gravity is a pulling or a pushing force. Raise your hand if you know the answer. What do you think? The gravity is a pulling or a pushing force? Ali?
Pulling. It's a pulling
Yes.
force. Because
Yes.
if something goes up, it's just going to pull it down.
Yes, exactly. So the gravity is a pulling force, okay? Because this is a type of question that you might see in any exam or any quiz. The gravity is a pulling force. We are pulled down towards the ground because of the gravity. The gravitational force is the force of gravity. The gravitational force pulls things down towards the center of the earth. Now, how was gravity discovered? It was discovered by a scientist called Isaac Newton. And I think you've heard his story several times before. So Isaac Newton was just strolling in a park, and he sat under an apple tree. And while he was sitting under an apple tree, an apple fell on his head. So normally, any normal person will just say, ouch. But Isaac Newton had an idea. And this idea what caused us to learn all of this force lesson. Okay, so Isaac Newton was sitting under the tree, and when the apple fell on his head, he said, I found it. Something is wrong. Why did the apple fall towards the ground? Why it didn't fly to the left or fly to the left or fly to the right, or just went up? Why specifically did it fall down? And this is when he realized that there is a force, an unseen force, a force that we cannot see, that is actually pulling everything towards the ground. Okay? So there is an invisible force pulling things to the ground. So he called it a gravity, the gravity force or the gravitational force. And this is the story of discovering what we call the gravitational force. Now, in order for us to go through the gravitational force, we have to know the difference, or we have to know what is the difference between two main terms, two words that we often get confused between them: the mass and the weight. Okay, the mass and the weight. All right, so this is a little bit confusing, so I want you guys to pay attention very good to what I'm going to say next. Okay, are you all there?
Yes.
Can you hear me well?
Yes.
Yeah.
Okay.
Yes.
Very good. All right, guys.
Yes.
So what is the mass? The mass is how much matter inside an object. What does that mean? It means that you have your bag, and this bag, your pack bag, for example, your school bag. When you are putting the books inside it, before putting the books, the bag is empty. There are nothing inside your bag, right? And then you start putting your books inside your bag. So you're filling your bag with books. This is exactly what the mass is, the amount of matter inside an object. This object could be anything in the world. It could be you yourself, the chair you're sitting on, the desk in front of you, your bag. Anything around you is an object which is filled with a specific amount of matter. Now, let me ask you a question, guys. If you filled your bag with 20 books, for example, if you took this bag and you went to the moon, will the number of the books change?
No.
Let me say it again.
It won't change.
Yes. So
It won't change.
just give me 1 second. You have your bag, you opened your bag, and you put inside your bag 20 books, and you closed your bag, and you flew this bag to the moon. You went to the moon, you went to Mars, you went to Jupiter, you went anywhere. Will the number of the books inside the bag change?
No.
It will never change.
They will stay the same amount
No.
of gravity, but just going to
Yes.
make it a little lighter.
No, Ali, just don't confuse the others, please. Okay, so we're talking about the mass now. So this means that the amount of matter inside any object, will be the same no matter this object is where. Okay, so your mass will never change because the amount of matter inside you is the same wherever you go. Wherever you go, the amount of matter inside you is the same wherever you go. Again, it's like you're filling your bag with 30 or 20 books. You took this bag anywhere, the number of books will stay the same. It will never change. So our mass and your bag's mass and your chair's mass, it doesn't change wherever you go. And the mass is the thing that we measure, or that we will be able to talk about, or say that it, for example, 20 kilograms. We will use its unit. The unit that we're going to use in order to describe the mass is the kilograms or grams. Okay? Are you with me, guys?
Yes.
Okay.
Yes.
Now, Miss, this is a
Can I go
little...
to the toilet?
Who are you?
Nancy.
Make it very quick because the next part is very important, Nancy.
Okay.
Okay. All right. Now, Miss, you're just confusing us a little bit. Why? Because there is another thing that we say. We're actually, when we say that how heavy I am, I say that my weight is 20 or 30 or 40 kilograms. You use the word weight. Well, this is where things get confusing because we actually are using the wrong word. When you say something about how heavy you are actually talking about your mass. You're not talking about your weight. The word weight is a whole new thing. Okay, let me get it clear. Okay, so again, if you want to say that how heavy you are, that it's 40, you say that my mass is 40 kilograms. My mass is 40 kilograms. Okay, now what about the word weight? What about the word weight? Weight is actually a type of force. Why? Because the weight is affected by gravity. If there is no gravity, there is no weight. What does that mean? It means that the weight is how much force the gravity will make to pull your mass down. Let me give you an example. Now, on Earth, you can walk very well on the ground. You don't have any problem walking on the ground, right? But when you go to the space, when you go to the moon, can you walk in the same way?
No.
No, you will start to feel like you're lighter and you're jumping, as you see the astronauts in the videos do. They start to jump or they start to float in the space because the gravity is much less than on Earth. And this is why your weight is related to the gravity. Your weight on Earth is different from your weight on the moon because your weight is always related to the gravity. Okay? Is it clear?
Yes.
Huh?
Yep.
Is it clear,
Yep.
guys?
Yes.
Yes?
Yes.
What? Someone is really lagging and he's asking a question.
Julie, and she's lagging, and she said yes.
She's saying yes. Okay. So again, the mass is not a force. The mass is not a force. The mass is a fact. This is how much matter inside the object. This is never changes, whether you are on Earth or on the moon or in Mars or wherever. Your mass is always the same, anywhere. And this mass is measured by the unit kilograms and grams. Okay, what about the weight? The weight is how much the gravity makes an effort in order to pull your mass to the ground. So the weight is always related to the gravity, and this is why your weight changes whether you're on Earth or on the moon or on Mars. And the weight is a type of force. Okay, the weight is a type of force, and when we measure the weight, we use the unit Newton because it is a type of force. Any force in the world, we measure it by the unit Newton. Okay, all right, so I'm going to ask you several questions, guys, and I want you to answer it. Okay, the first question: what is the unit of the mass? Raise your hand if you know the answer. What is the unit of the mass? What is the unit of the mass? Only how many people
Miss,
do I have?
what is
The
what?
unit. What is the unit of the mass? What do we use in order to measure the mass? When we are describing the mass, what unit do we use? 4 people only. Where are the rest? What is the unit of the mass, guys? The unit of the mass. When we say how heavy we are, we say I am 40 what? I am 40 what? Okay. Ahmed Ahmed. Ahmed Ahmed.
Yes, miss.
Yes. What is the unit of the mass, Ahmed?
Kilogram.
Yes.
I
Grams,
can't remember.
grams or kilograms? Grams or kilograms? Thank you, Ahmed. Now, what is the unit of the weight? What is the unit of the weight? It's the same as the name of the scientist that discovered the gravity. What is the unit of the weight? Yes, Ruqayya? Do you know?
I know.
Yes. Yes, dear. What is the unit of the weight? It's the same name as the scientist that discovered the gravity.
Isaac.
No, it's not Isaac. Any force has one unit, and the weight is a type of force. Okay, I will take someone else. Who is Mira? You're Mira. Yes, Mira. What is the unit of the weight? Newton, exactly. So because the weight is a type of force, because the weight is affected by the gravity, we measure it using the Newton. We say that its unit is Newton. All right. Now, my next question is, which one of them is a force? The mass or the weight? Which one of the two terms is a force? The mass or the weight? Which one of them is a force? Which one of them is a force? Yes, Julie.
Weight.
The weight, excellent. The weight is a force. The mass is not a force. Very good. Thank you, Julie. My next question is, which one of those two changes according to where we are? Which one of those two changes according to where we are? Ali.
Again, weight.
Yes, again, weight, exactly. So the weight is the thing that changes wherever we are. If we're on Earth, it is affected by the gravity of Earth. So the weight on Earth will be different than the weight on Mars, than the weight on the moon, because each one of those planets, and of course the moon, has its own gravity. Okay, so and the weight changes according to the gravity. So the gravity of the Earth is different from the gravity of Mars, is different from the gravity of the moon. So each one of those planets, we will have a different weight on them. Can you believe this? We will have the same mass because we will never change the amount of matter inside us. But because the gravity changes in each of those, our weight will change because our weight is always affected by the gravity. Okay, is it clear so far, guys?
Yes.
Is there
Miss, can
any?
you say that?
Yes.
Can you say this
Yes.
part again because I got disconnected?
You say what?
Can you say this part again because I got
I
disconnected?
didn't say anything new, Ruqayya. I was saying that I'm just repeating the same thing over and over so that you can understand it. Okay, and you can, yeah, you can watch the video. I'm going to upload it on Classera. Rewatch the last part. You will not be missing anything. It's the same thing. Okay, so again, the mass is the amount of matter inside an object. How can I remember this? You can remember this by remembering the example of your school bag. I have a school bag, and inside this bag, I put 30 books. Okay, excellent. If I am in the school, the bag will have 30 books. If I took this bag and went to the club, the bag will still have 30 books. If I took this bag and traveled to Spain, the bag will still have 30 books. If I took this bag and traveled to the moon, the bag will still have 20 or 30 books. Okay, so the number of matter or the amount of matter inside any object is your mass, or its mass, and it will never change. Okay, and we can measure it using the kilograms and grams. The unit of mass is kilograms and grams. Now, what about weight? Weight is our mass affected by gravity. Weight is our mass affected by gravity. So weight is always related to the gravity. And this is why weight is changeable. It changes from one place to another. If you're on Earth, you are affected by the gravity of Earth. So your weight on Earth will be X. And when you go to the moon, the gravity will change. So your weight will change because the gravity changed. If you went to Mars, the gravity will change. So your weight will change because the gravity changed again. So the weight is related to the gravity, and the gravity is a force. And the gravity is a force, okay? So the weight is a force too. And since the weight is the force, the unit that we use to describe the weight is Newton. Okay? Because who discovered the gravity?
Newton.
Yes, Isaac Newton. Okay, so any force in the world, we called it Newton because he was the one who discovered the concept of force. Okay, so any force in the world, we call it Newton. Okay, or we use the unit Newton to describe it. Okay. Now, I don't think we're going to say anything else because we have like 5 minutes or so left. So, okay. So let me just say the last thing that is written here. I will ask you a question, guys. As I said, weight is the gravity times the mass. This is the law of the weight, okay? As you can see, it is your mass and how much it's affected by the gravity, all right? Perfect. So this means that the more your mass, the weight will be more or less. If you have a very large mass, your weight will be large or small?
Miss, can you say again?
Okay. As I said here, can you see the law right there? The weight is your mass times gravity. And this is why I'm telling you that your weight is your mass and how much is affected by the gravity. Now, my question is, if I increased the mass, if I made the mass more, if like instead of 20 books inside your bag, I added even more books, it became 50 books inside your bag. Do you think the weight will be affected?
No.
Yes.
It will be affected because the weight is affected by the mass and by the gravity, both of them. The weight is affected by the gravity and the mass. So if you made the mass more, the weight is also going to be more. Do you understand, guys?
It will be heavier.
It will be
Yes.
heavier, exactly. It will be heavier. Very good. Okay, guys, so I'm going to end the session now. This is what we're going to take so far. This is enough for you for today. I will be uploading this PowerPoint on Classera. So I want you to go through it again. And if there is anything that you're confused about, just tell me tomorrow so that I can re-explain it for you. Okay?
Okay.
Bye, guys.
Bye.
Bye.
Bye. Bye.